Can you do me a favor?
What would that favor look like?
It would look like you pulling up the 3D printed houses being constructed by the algorithm laser or whatever the fuck.
This house was built in 28 hours. How? By using the 3D printing technology. Alquist 3D used giant printers to build houses using concrete instead of wood. It helps save up to 15% per square foot in building costs. It's also resistant to tornado and hurricane damages. Would you build your house using 3D printers?
Yes. The answer is yes.
The answer is definitely yes.
The answer is, I think, yes.
Ever seen a concrete printed house? Let's go inside and I'll show you some details. All right, so one thing I love about this house and this technology is that the walls and the printing run from inside to out. So there's no drywall on the inside. This is just that concrete that's been painted on the inside.
It looks
and
cute.
Then for a little bit of trim, they've got a stucco parge coat where the windows are.
Smart.
But check out the gorgeous kitchens, the curved walls. There's some
I
amazing
love the curved wall. I'm entranced. Do 3D printed jobs take away jobs?
It's very important to know that the machine only builds the structure, which means we still need plumbers, electricians, HVAC, carpenters for kitchen, baths, flooring, windows, doors, molding, trim work. We need roofers. Yes, 3D printed homes compete directly with framers, but it also creates higher paying jobs in the tech industry.
Let's go through these articles that I read. 3D printed homes will be the Teslas of housing. It's no secret America is in the midst of a housing shortage, with home prices ballooning, supply remaining stagnant, and would-be home buyers frantic to secure an affordable place to live. Supply chain backups due to the pandemic made building materials more expensive, and there's a labor shortage too. 3D printing homes would totally help because of the labor shortage issue specifically. Oh, this is interesting. He's talking about how homes that were built 100 years ago were a lot sturdier and they were just a better build than the homes constructed today.
Yeah.
He's saying that construction quality and materials have devolved to a point that this is the reality. The decrease in quality hasn't enabled the quantity we need. The US builds 2 million fewer homes than needed each year. The lack of supply then feeds a cascade of related problems. Builders resort to less skilled labor and cheaper materials. So there's a lot of cost cutting. And then city regulators add to the problem with strict zoning and building requirements. That leads to what he calls soulless housing, cookie cutter subdivisions where every house looks the same. Zooming out of the US, there are 1.6 billion people around the world who lack adequate housing, whether they're in unsafe buildings, shanty towns, or completely unhoused. So the way that the 3D printer works, by the way, it's called the Vulcan. It builds homes by pouring a concrete mix into a software dictated pattern. Instead of one wall going up at a time, one layer is put down at a time. So the whole structure is growing up from the ground up. The idea is to make more homes, but also better homes, better quality, and at a cheaper cost.
Yeah, I'm for it.
Here's another article from Time, how the company behind TikTok's viral 3D printed houses wants to help solve affordable housing crisis. This is Alquist 3D. So it's a giant robotic arm methodically depositing layers of concrete. Yeah, they're just talking about how it's transfixing, which it totally is.
Yeah.
Most millennials are open to this paradigm shift.
We all see the housing crisis. It's real.
The concrete exterior of the 1,200 square foot home was constructed in just 22 hours. It's saving time. It's saving money. You still need the electricity, the plumbing.
Need all these people.
Right.
But it's saving time and it's making it cheaper.
Exactly. Making it affordable. So the problem that they're facing with 3D printed housing is scale. How are they going to do a lot of it?
The printer itself is extremely expensive. And then you also would have to have people that know how to operate it.
Right.
And if you're already a construction company, that's not something that's probably like a viable way to switch over.
He says that while 3D printing has long-term potential to transform the construction industry, America's penchant for building houses with light wood framing is a major challenge for wider implementation of technology that relies on concrete. Since labor and supply chains in the US are set up to handle wood, I guess that would upend that whole situation. But also logistically, installing and repairing the plumbing, the electricity, HVAC, and other systems within concrete is more difficult to access.
But what if I told you that Italian architects designed the world's first 3D printed house out of dirt? Yes, dirt. Now, clearly the hype hasn't bitten the dust yet, so let's take a closer look at what this means for the future of building sustainable homes and if they're all that they're cracked up to be. Based on a sketch, the 3D printing machine uses the so-called additive manufacturing process to create the real object in a multi-layer manner. As for SLS, the 3D printer solidifies a photosensitive powdered polymer by hitting it with a powerful laser light. FDM-based machines melt thermoplastic polymers that become solid once it cools. That's how the very first 3D printed house was created in 2014. Now it's time to dish the dirt on the Italian 3D printed clay-made house. Mario Cucinella Architects came up with an original 3D printed concept. Well, they copied it from the mason wasps, to be honest, but I guess insects can't sue you for violating a patent. The Italian architects crafted a beehive-like structure out of locally sourced clay. To do so, MCA used a 3D printing technology developed by a company called WASP. I know, they're not buzzing with originality. Jokes aside, how does that
was
work?
a dad joke.
Well, WASP developed a software package that allowed the simultaneous control and operation of 2 printing arms. The company claims this software is the first of its kind anywhere in the world. After mixing raw earth from that location with water, the 2 3D printers scored out 350 layers
That's so
of clay
cool.
in a wave-like manner to ensure structural stability.
It's
They
gorgeous.
also use rice waste in the goop to increase the insulating properties. When it's complete, you have 2 interconnected dome-shaped units, including an open-space living room and an ensuite bedroom. On top of that, WASP machines can print furniture like tables and chairs as well. And creating a cupola was a smart choice as it lets you build walls and roof in one go. Also, the 3D printers spit out domes one section at a time. Now, while limited to 1 floor only, this modular approach makes the habitat horizontally scalable. The group named their method Tekla, linking technology and clay. The idea is that by building this house, no waste is generated.
Watching these videos for me make me feel so undisciplined. Like when I see some guy like drawing a fucking blueprint for a
Yeah, he's like sketching it out.
futuristic clay robot house.
Just casually, just like, yeah.
And I'm like, oh God, I feel so lazy compared to him.
Different people are meant to do different things.
I know.
Remember the $1,000 figure mentioned earlier? That's covering just the walls of WASP's 3D printed creation. However, when you look at the Fibonacci house recently 3D printed in Canada, walls accounted for only 6% of the overall outlay. Tekla's still in its early stages and needs to go through structural
The
and thermal
Fibonacci
testing before it's
overlay?
scaled up. So it's tricky to have an accurate price
So cool.
at the moment. In fact, as mentioned by Cobod's CEO, you need to 3D print at least 10 houses to provide more reliable estimates. However, these costs change around the world. So 3D printed houses will be cheaper in some countries compared to others. And things get even more muddy when you get some bad press, or too good to be true press, I should say. Respectable publications reported that Icon would have 3D printed a house for as low as $4,000. However, when interviewed by the YouTuber Jarrett Gross, Icon's founder labeled that figure as a mishap.
It's funny that the Icon guy, he wants to be known as the Tesla of 3D printed houses.
Yeah.
Housings.
It's giving me Elizabeth Holmes.
A little bit.
Of like, yeah, we'll make it affordable and it'll be super cheap and it'll be the best. Do they hold up in the weather? How much do they actually cost? We don't really know.
The next point, surely a house made of dirt must be green, right? Well, while being touted as a zero waste paradise, Tekla actually isn't. Like any other 3D printed house, it's got its feet of clay. That's because WASP's 3D printers can't gush out the finishings, plumbing, electrical, wiring, and all the other household appliances out of clay yet. They envisioned their housing system as part of a low-density eco-city. Ironically, this sprawling effect comes at an environmental cost. For instance, inking the natural landscape with fragmented human settlements gets in the way of wildlife. Living remotely requires transportation, which means added air pollution unless you can afford an electric vehicle with long range. On the other hand, your emissions get lower in denser cities. People living in Toronto's low-density suburbs emit up to 2.5 times more greenhouse gases than the high-density urban residents. Another study found that doubling US cities' density would drive down travel emissions by 50%. As of 2005, the United Nations counted 100 million people homeless around the world, and 1.6 billion live in poor state houses, which will be 3 billion by 2030 according to the UN Habitat. Just put that in perspective, this is nearly half the world's population.
It's going to double in the next 10 years. That's what he's saying. These stats are shocking. I mean, we were talking about it privately, but there are 33 empty properties for each homeless person in the US. And since 2010, the number of empty properties per homeless person has increased 24%.
The housing is so unaffordable. Renting a place, you're supposed to make 3 times the rent. The average person is not making nearly that amount. You also have now like an in-between class of houseless people now where they're like mostly like dwelling in like cars or like camped in like RVs and stuff like that. So they're not like traditionally houseless, but they've been squeezed out of the market.
Right.
Or they can't afford it, but they're still working in your grocery stores and at your Starbucks and stuff like that.
Right. So just so I understand, we're 1 million to 4 million houses short every year, yet there are 33 vacant homes per every homeless person. So in other words, the people who can't afford houses, they're the ones that are getting rather competing over the
limited amount of housing.
Yeah.
Which is driving the prices up.
Yeah. And then creating more homelessness.
And then creating, yeah.
It kind of fucks with my head.
Because it's so fucked. It's like so evil and insidious because it's like, why? Why are we doing it like this?
Yeah.
There's no need to do it like this other than greed.
To alleviate the housing crisis, we're pressed for time and we need to churn out 96,000 affordable homes every day. That's what I call a long printing queue. Now, even if wasp nozzles were to go full blast, we need to read the small print carefully. Let's pick a country like Kenya, for instance. Nicholas Patel, who runs a construction company in Kenya, turned down the hype on the feasibility of 3D printing housing in the African continent. First, you need to factor in the carbon footprint and cost of shipping wasp kit all the way to Africa. Then you'd have a lot of local challenges, such as lacking or poor infrastructure, legal issues, and the need for security 24/7. 3D printing may have a negative impact on countries having a lot of low-paid construction workers. Because of its potential in reducing waste and emissions, 3D printing could play a key role in the decarbonization of the construction industry. On top of that, this automated building process could knock down execution time and expenses. Even with these advantages, though, the technology is still in its infancy and cost reduction expectations are still to be confirmed.
Okay, so give it 50 years, right?
Yeah.
That's kind of what I'm taking from that.
It's not ready yet.
Right.
We'd have to have it on a large scale.
For sure.
Give me the